this is the next assignment to be working on, so 543. And so we've kind of done some stuff on creating multi-view drawings from isometrics. We've created isometrics from isometrics. Now we're gonna kind of see where it goes. And so here I've given you two views, and you're gonna need to finish this view here, and then also create an isometric of this part. Okay, does that make sense? So how would you even go about that? How would you figure out what's here given these two views?
Based on the layers on the right side, it looks like it's a step of some kind, like 3 steps.
Yeah. So we've got kind of there's some lines here, right? And some lines here, which let us know that there's something going on in there, right? If we ignore all the hidden lines, we just had the solid lines. So if we just had this, oops.
We'd use the minor line?
This, well, that could be part of what we do. But if we had just these two, a lot of stuff could be going on here, right? Like this first section here could be straight, and then it could be angled, and then it could be curved or something, right? Or it could be flat, 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 like that. There could be a lot of things, or it could be angle, angle, angle. Right? If I had an angle going to there, then flat, then another angle, if my line's lined up. Right? If those things lined up. Oops. That could be what that is, right? But what do you think it is?
I think it's 3 steps.
Yeah, it's 3 steps. How do you know it's 3 steps and not any weird angles or anything?
Because of the holes.
Yeah, because the hidden lines. If it was at an angles, these hidden lines would have different start and stop points, and the tops of them would be like ellipses and things like that. They wouldn't just be flat. Since they're flat there, you know, okay, it's steps. And so there's 3 steps on it, full height, half, and then down here. And then what's going on your steps?
We have cylinders, cylindrical things.
What are those cylindrical things called?
Holes.
Holes. So we have some holes in this thing. So these bottom ones, so these two, where are those in the right side view?
Bottom.
Yeah, it's these two. How do I know that those are them? Someone said the magic word earlier. The miter line. So if I drew from here straight across and drew from here straight up and then drew a 45-degree line, and if I had a 45-degree line that actually worked, that's going to come down to there. That one's going to go over, hit the line, and come down to there. Same thing in the back. It's going to go over, come down to there, go over, come down there. Drawing them with the mouse sucks. But you get the idea, right? So you could use that miter line and see what lines up with what. And that's an easy way to figure out, okay, where does this thing go? So what is this thing right here? That's countersink, right? So that's this one here in the middle. What's this? Counterbore. Oh, what's going on down here at the end? Yeah, that's the drill bit. That's the angle bit from the drill. What angle is that? Yep, pretty much. So if that end of the bottom of that like this included angle right here is 118 in real life. We draw at 120. So that way, this is 30, 30, and this is 30. So we can use our polar tracking set at 30, and we can draw that in real quick. So we just draw the bottom here, and then connect it. Is there an error on the bottom of this thing, on the side view at all? Is there anything wrong with that? Anything missing or extra?
Would it be the countersink? The bottom of the countersink?
No? Bottom of the countersink, this?
No, that's counterbore.
Yep, the countersink? Nope, because it goes all the way through.
Is it the two small holes at the bottom?
No, those look good. Look at this. Which one of those is right?
The one on the left.
Which one is correct, I mean?
The one on the left?
The one on the right.
Makes you think that there's a triangular hole on the backside.
If the... Okay. So what do you guys think? Who thinks... So people online, you can use your... The...
No, I'd
Where's
say
it?
the right hole's correct.
There's
because there is an edge.
the reactions or whatever. Who thinks that the one on the left is the correct one? So I have 4 people in class, 1 person online. What about the one on the right? Who thinks the one on the right is correct?
Let's say that one, yeah.
4 people in class, 2 people online, 3 people online. So it is the one on the right.
We have to draw right there.
That's the correct one?
Yeah, the one on the right is correct. Because there is an edge that goes all the way around, right? Because between where it goes down straight and where it angles, there's a sharp corner there, right?
Yeah.
And that sharp corner goes all the way around the hole. So there's a line there. Okay? So it should be like this one on the right. It's just the same exact reason why there's a line here and there's a line here. Does that make sense? All right. Oh, I guess I could have done that. So, let me clear this out. Any questions on this? So why am I making you do this?
So we actually know how to do it.
Yeah. But also, when you get a set of plans that someone gives you, you have to try and figure out what's what, right? This skill of trying to like, okay, what over here matches up with up here, and then how does that relate to what's in the front view? That's a good kind of visualization exercise to do. So that's why we're doing this one on something that's kind of easy to work through and see, okay, how can I get what this is supposed to look like? So do that. So first thing, draw these out, put this in. So these squares, I don't care what scale you use. Do it 1/10 of an inch per square, 1/4 inch per square. I don't care. It's up to you, okay? But draw it in 2D in AutoCAD, all 3 views. How are you gonna do that? How are you gonna approach that? What steps would you take?